Hello everyone, let's solve the next question. Here we are given that a particle of 1 kg has a velocity of 2 meter per second. A constant force of 2 Newton acts on the particle for 1 second in a direction perpendicular to the initial velocity of the particle. We have to find the velocity and displacement of the particle at the end of 1 second. Let's first draw the diagram. Suppose the particle is moving in this direction. Let this be the initial velocity u vector, and its magnitude is given as 2 meter per second. So we can write this as 2 meter per second. Now we have been told that mass of the particle is 1 kg. So we can write m is equal to 1 kg. And a constant force of 2 Newton acts on the particle for 1 second in a direction perpendicular to its initial velocity. Suppose in this direction a constant force F is equal to 2 Newton acts on the particle, which is in the direction perpendicular to the initial velocity, direction of initial velocity. Therefore, the path of the particle will be in this way. Since the net acceleration is perpendicular to the uniform initial velocity, the path will be in this way. So we can now find the acceleration of the particle, which will be in this direction. That is, a is equal to f by m, that is f upon m, which is 2 upon 1, that is 2 meter per second square. Now, at the end of 1 second, let the particle be at this position. Let this is be t equal to 0, and this is be t is equal to 1 second. Now we can use the equations of uniformly accelerated motion in this case, and let this be x direction and this be y direction. So we can apply equations of uniformly accelerated motion in both x direction and as well as y direction. Let's first find the velocity of the particle at time t is equal to 1 second. Now in this direction the velocity will always be 2 meter per second. Since there is no force, its velocity in the direction in x direction is going to be constant. So ux is equal to vx at time t is equal to 1 second is equal to 2 meter per second. Now we have to find vy at the end of t is equal to 1 second, which we can write as uy plus ay times t. V is equal to u plus at. This equation we are applying in the y direction. So we can write uy as initially the component of velocity in this direction, that is y direction, is 0. So we can write 0 plus acceleration is 2 times time is 1. So 2 meter per second. That is, after 1 second, the component of velocity along x direction is going to be in this way, that is 2 meter per second, and the component of velocity along y direction is going to be same, that is 2 meter per second. So net velocity will be, we will be getting by joining both these two vectors, and the net velocity will be in along this direction. This is the v vector. So we can write magnitude of v vector as square root of this 2 square plus 2 square. So this is going to be 4 to the 8, that is 2 root 2 meter per second. This is the magnitude of the velocity when the particle is at t is equal to 1 second. And we can also find the direction. Since we are asked the velocity, so we have to determine both the direction as well as magnitude. And we can find this angle theta. So we can write tan theta is equal to 2 divided by 2, that is 1. This implies theta is equal to 45 degree. So we can write the velocity at t is equal to 1 second will be 2 root 2 meter per second in the line which is making an angle of 45 degree with the initial velocity. So this is the answer of the first part, that is the velocity of the particle at t is equal to 1 second. Now let's find the second part. Here we have acceleration as 2 meter per second square. Now we have to find the displacement of the particle at the end of 1 second. In this direction, the velocity will be uniform since there is no acceleration along the x-axis. So along x, the displacement will be, simply we can write distance is equal to speed into time. So we'll be getting 2 times 1. This is the speed along this direction and time is 1 second. So we are getting 2 meter. And displacement along y, for this information we can write s is equal to ut plus half t square, uy times t plus half times uy times t square. Here initial velocity along y direction is 0 times 1 plus half. Acceleration along y direction is 2 times t square, it is 1 square. So we are getting 1 meter. That means if we draw the vectors along x direction, the displacement vector will be this one, that is 2 meter. Along y direction, displacement vector will be 1 meter. So net displacement will be along this vector. Let this angle be theta this. Now let's first find the resultant, the magnitude of the resultant s vector. So magnitude of net displacement vector at t is equal to 1 second is under root of 2 square plus 1 square. That is root under 5 meter. This is the magnitude of the displacement at t is equal to 1 second. Now let's find the direction. Tan theta this is equal to 1 upon 2. That is half. This theta this is equal to tan inverse of 1 by 2. That means we can say that the displacement at t is equal to 1 second is root 5 meters along the line, which is making an angle of tan inverse half with the initial velocity or with the direction of initial velocity given. This is the answer of this question. Thank you.